Right, checking 1, 2, 3. Right, it is good, but it is like 25-second delay. Oh, it's fine. Right. So before we start, just want to review something we have last week, and so we make that like put that in the 3x5 or the quick reference card. Right. So most important thing is, of course, we defined the trig function. Let's do this. Right. So there's a background around. So we define the trig function using x, y, and r. Sine is y over r. Cosine is x over r. And tangent y over x. It's not that clear. Better. And then reciprocal of sine is cosecant r over y. Secant reciprocal of sine. So we're going to flip r over x. And then cotangent x over y. So we're going to flip those ratio, and that's what we have. Right. So that is the basic definition of trigonometric function. On the back, now some special values are 0, 30, 45, 60, and 90 degrees. So you can write on the back of that reference card. Just write on the back of it. So just one. Never mind. Right. For special values, we have the special values 0 degree, 30, 45, 60, and 90. So those are the values that I expect you to can get the answer rather quickly. And the trick for that, of course, is we use the right hand. Or left hand, it doesn't matter. I'm just going to draw a hand here. Most important, 5 fingers. Right. 30 degree. I'm sorry. 0. 30, 45 degree, 60, and 90 degrees. We go counterclockwise as always. And then we use the just sine, cosine, and tangent. So the way we define sine of an angle is equal to square root of just, for example, if corresponding to 30 degrees, we're going to cover the 30 degrees. Or if we do it by hand, we just fold the fingers like that for 30 degrees. So 3 on the left and 1 on the right. And sine will be the numbers of the finger on the right, square root of that, divided by 2. Cosine is the number of the left, the finger on the left, divided by 2. And then tangent, number on the right, over the square root of the number on the left. Right, so those are the quick reference chords that we go back and forth, and that's what we have from last time. Right, get back to this. Right, today is 7. And we go to section 1.4, reference angle. Reference angle. The definition is because on that side it says that the reference angle of theta is we denote by the prime sine, which is an acute angle, meaning from 0 to 90 degrees. And that acute angle will match with the terminal sine No, that was wrong. The definition, I think and either positive or and the x-axis. Right. Not the positive x-axis. I think notice the typo. Right. So the key here is it has to be from 0 to 90 degrees. Because it could be equal to. That is important. Right. I'm just going to draw by hand so it will be quicker. So let's say we have an angle here. We have that angle. So by definition, it is an acute angle formed by the terminal rate, and the x-axis could be positive, could be negative. What? It is going to be the same. Reference angle. We use that symbol. So in this case, theta is equal to theta prime in the quadrant 1. In the first quadrant, it will be the same. Right. On the second quadrant, second quadrant a second quadrant angle is that. Now what we're trying to form is an angle with the terminal rate and either positive or negative x-axis, but it has to be acute. So the goal here is to make an angle using the x-axis, could be either on this side or could be on that side, and the terminal rate. So we have to use this side because that's the only option that gives us the theta prime. So sometimes we use the one on the right, sometimes we use the one on the left. Just whatever give us an angle between 0 and 90 degrees. That's what we use. So in this case, they add up to 180. Or we can write theta prime is 180 minus theta. Right. Quadrant 3. That is an angle in quadrant 3. And we try to form using the terminal ray and either with the negative x-axis or the positive x-axis. So we might use this angle here or use the terminal rate and the positive x-axis is angle there. So we have to use this one because it has to be an acute angle. Because of that, we know that the angle theta, take away 180 degrees, half a revolution, give us theta prime. So in this case, we have theta prime equal to theta minus 180 degrees. So that, the angle in quadrant 3, the reference angle is that. 4. It's in quadrant 2, quadrant 4. Now quadrant 4. A standard position angle going like this. That is angle theta. And we have to use this terminal rate. This terminal rate, make it with either the positive or the negative. Whatever gives us an angle between 0 and 90 degrees, that's what we take. So in this case, we have theta and theta prime together, make up one revolution. So to solve for theta prime, 360 minus theta. So we have 4 different scenarios, 4 different quadrants. And we have different scenarios for the reference angle. Right, see example. So the key here is terminal rate, terminal sine, and the x-axis. Whatever gives us an acute angle, that's what we take. So for 250 degrees, what do we have? Right, just trying to draw that. Right, so 250 degrees. So if we have to do that, and let's say we use the calculator, 250 divided by 360. So have 69 something. So that means it is about 69% of the whole revolution. So more than half, but less than 3/4, right? Again, we have 0.69, meaning that it is more than half, but less than 3/4. So this is half a revolution, 3/4 of a revolution. So this is in quadrant 3. And we have 250 degrees. In quadrant 3. So how do we find reference angle? The reference angle is the terminal sine and either positive or negative x-axis. Whatever gives us a positive acute angle. So that's going to be theta prime. So obviously we're going to take 250 degrees and then we take away 180, give us theta prime. So theta prime is equal to 250 minus 180, and that is 70 degrees. So the reference angle is 70 degrees. Right. It has always have to be between 0 and 90 degrees. Two. 130 degrees and 24 minutes. Right. So if we use 130 degree and 24 minutes, divided by 360. So this is 0.36. 0.36 is more than a quarter, and less than half. So that is in quadrant 2. This is a quarter, and this is a half, and that one in the middle. So we have 130 and 24 minutes. And so we're going to make it a reference angle. We use this terminal sine and we form with this axis. So the angle will be acute angle. So pretty much we take 180 minus that. So 180 degrees minus 130 degrees, 24 minutes. Right. How about convert this to degree in minutes second? 49 degrees. So we take 180, the whole thing, take away theta, give us theta prime. Uh, 49 and 36 minutes. Right. So we're going to make an angle using the terminal sine and an x-axis, positive or negative, whatever give us acute angle. 3. Negative 400 degrees. So negative 400 divided by 360. like negative 1.11 something. First of all, it is negative, so it will go clockwise 1 revolution clockwise, so that's negative 360 degrees, and it will be a little more. So this is theta negative 400 degrees. Yeah, the whole thing. Right. Now, if we want to make a reference angle, it has to be this one. So first, if we want to, we can always add 360 to it to have a coterminal angles, and we do that, we have negative 40 degrees. Negative 40 degrees, of course, will be just this part here, and so the theta prime is also that much, so theta prime is 40 degrees. Okay. So reference angle coterminal angle is negative 40, which is this, and reverse that, we have theta prime for 15 degrees. Either we add 360 or minus 360 to bring that into within 1 revolution. So in this case, let's minus 360. We can add or subtract a revolution to it. So the answer between 0 and 360, right, 55 degrees. So we use 55 degrees instead. 55 degrees is in the first quadrant. Because of that, that is also the theta prime. So we have to determine what quadrant it is, and then different scenario, different things. The key here is whatever the terminal sign is, make with the positive x-axis or negative x-axis. The angle has to be within 0 and 90 degrees, an acute angle. Next, what do we need the reference angle for? This is very important. Right. Now, we use this to find the values of any trigonometric function. However, if we want special values, this is what we can only do for now. So we'll get back to that. So the first thing is we have this theorem. Let theta prime be a reference angle. Then we have this theorem. Right. Rather writing like that in the note, what I write instead is in this form. I think this is easier to write than the one we have on the note. I will write sine of theta equal to plus or minus sine of the reference angle, and this applies for any trig function, sine, cosine, plus or minus cosine of theta prime, and tangent plus or minus tangent theta prime, cosecant secant and cotangent. So the only difference here is form of an angle to a reference angle. It can only be different by the sign. So that is the important things. That is trigonometric values of an angle and the reference angle. Only difference only difference by a sign. Meaning it could be positive, could be negative, could be the same, or could be opposite. It's only different by the plus or minus sign. And that is the big deal. So because of that, we go to the second step. So to find the trig values of any angle. First step is to find the reference angle. To find trigonometric function values of any angle theta, first find the reference angle. And its values. And then use the Quarren to determine the sine. Right. So let's review. What we have is the definition of the sixth trig function, right? And then after that, we have this hand trick to find the special values of these angles. Right. So how do we determine the sine? Actually, we did this last time, so I will write that on this quick reference card. And it's not really anything big. So if we know the point in the quadrant, we can determine if it is x, y, could be positive or negative. It's r always positive. R is always positive. x and y could be positive, could be negative. But when we put all together, we have this mnemonic. Like that is quick reference, so I just write the mnemonic. Let's say I use own store text cash. So in the first quadrant, all of them are positive. On the second quadrant, there will be sine and subsequently cosecant. On the third quadrant, this is tangent are positive and cotangent. And on the last one is cosine. Right. So put that in the reference about the sine, and this reference about the values. Right. So we're going to use this two for the next example. But before we do all of that, now it's very important. By the way, do you have any question up to this point? Right. So now up to this point, we can only find the trig values of these special values, right? 0, 30, 45, 60, and 90. Right. Now, what we do, usually it is like the multiplication table. When we do a lot of them, we get used to it. But for now, we don't. So that's we use the trick to do it. Usually, even I don't try to memorize all these values like the multiplication table. What I actually do is, I just use this, but I'm going to do it in my head, and I used to it, so I do it rather quickly. But like I said, there's no trick to it. We just do it, and whether we do it quick enough or not, it doesn't really matter. The way we do it is still the same. Right. Here's the thing though. Again, we can only find the values. We only know the values of 0, 30, 45, 60, and 90 degrees. Those are the special values. If it's not any of this or any combination, it will be this. Right. So let's say this. Now, we're talking about 0, 30, 45, 60, and 90 degrees. Right. If, let's say, for an angle theta. Now, if theta is divisible by (90°), by divisible by, I mean, if we take an angle like 270, divide by 90, it will come out nice and even. That's what I mean, divisible by. Or I should say, it's a multiple of 90. Then use x, y, and r to find its trig values. So we're not going to use anything special if it is divisible by 90. What would be special is what we do next. Now, again, 0, 30, 45, 60, and 90. So if it is divisible by 90, that's special. We're not going to use the hand trick. We only use the hand trick for 30, 45, and 60, actually. Now, this is very important. We divide by 60 first, and then 45, and then 30. Always in the decreasing order. Try to divide by 60°, 45°, or 30°. In that order. Right. Now, if it is divisible by 60 degrees, then the reference angle is equal to 60 degrees. If it's not, then we go to 45. Then the reference angle is 45 degrees. And if it is divisible by 30, it will be 30 degrees. And once again, only work for 60, 45, and 30. And we try 60 first. If 60 doesn't work, go to 45. If 45 doesn't work, go to 30. And if 30 doesn't work, we have option. That's all we do, really. Only do those three things, and usually that will be enough. Alright, so that first. And next, we determine the quarren. To determine the quarren, divide 360 degrees and take the decimal part. And then after that, we will have 0, a quarter like 0.25, a half 0.5, and 0.75. It will be in any of those quarren. So that is how we determine the quarren. For example, let's say if I pick like 1,000 degrees, what quarren is that? I will divide by 360, and it is 0.778, right? I take the decimal part only, meaning that I ignore the 2. Just take the decimal part, 0.778. That of course will be bigger than 75%. So this will be in the fourth quadrant, 1,000 degrees in the fourth quadrant. So that's what we do, right? Divide by 360, take the decimal part, and then it will be in between this. Right. So again, we need two things: find the reference angle, and then find the quarren. The quarren determine the sine. The reference angle determine the values. Right. Now that's just like the cookbook recipe. How do we actually do it? Right. Let's see. B. Example. Find the exact values of the trig function. Right, first one. Sine of 120 degrees. Right. Now we use the quick reference card that we have earlier. Right, sine of 120. First, I'll just take 120. Actually, when we used to it, we will do this very quick. But for now, just do it in slow motion. Right. So, say 120 divided by 90. So it's not 120. So we try to divide by 90 first. If it works, then we don't do any of this. So it doesn't work. Now we divide by 60. So that come out even. So we say, so the first thing we do is 120. We don't even need to write this. When we divide by 60 degree, it is 2. Because of that, we can say the reference angle is equal to 60 degrees. Right, like I said. The question usually just asks us about the special values, so we have that. Right? 60 degrees. Now next, what is sine of 60 degrees? Now we do the same trig function for the reference angle. Sine of 60 degrees, right? Okay. Right. So 60 degrees. Where's the eraser? It's fine. 60 degrees. I don't want to use something else. Right. 60 degrees. Put that in 60 degrees. And the sine is the number of fingers on the right. We have 1, 2, 3. So 3 fingers on the right. So we take the square root of that. Divide by 2. So we know it is going to be square root of 3 over 2. The next part is determine positive or negative. So first we have the values. Square of 3 over 2. Next, the quarren. How to determine the quarren? So we take 120, divide by 360. Like I said, I'm doing this problem in slow motion. When you get used to it, we can do this very quick. So 0.333. So if it is 0, 0.25 and 0.5, 0.75. 0.33 here is between 0.25 and 0.5. So this will be in quadrant 2. And then either we use this mnemonic or store take cast in the second quadrant, sine is positive. So this one is going to be positive. But we can also do this. Sine is equal to y over r. And in this particular y value is positive. And r always positive. Positive divided by positive is positive. So we have the positive and that values. So the answer is positive and square root of 3 over 2. So we say sine of 120 is square root of 3 over 2. I know I do this extremely long and older step, but that actually on the step what we do. When we used to it, actually when I do it, I just do all of this on the top of my head, and I get the answer quickly. I did not memorize any of this. Don't need to memorize any of these values. Right. So use the reference angle to find the values and use the quarren to determine the sine. We need the values and we need the sine. Right, moving on. Oh, we have a lot of this, which is good. 1. Right. So first thing, where was that? Okay. 1320 divided by 90. Right, good. If it's not, right. I said this all the I should not unnecessary step, and just all the steps are there. We just go extremely slow. We can get the values rather. It's almost no room for error. I mean, there should not be any error if we do carefully enough. Right. So 1320 divided by 90, that doesn't work. So that's we're not gonna use that. Now divide by 60. So 1320 divided by 60. Does that work? 1320 divided by 60. It works too. It is equal 22 even. Because that division by 60, then we can say the reference angle is 60 degrees. Right. If it does not, we go to 45. If it doesn't work, go to 30. And if it doesn't work, go to the calculator, because there's no special values for that. Right. Try 60, 45, and then 30. Other than that, we have to try something else. Right. And then we find the trig values for that reference angle. Like that, the hand trig 60 degrees is that, and 3 fingers on the right, so square root of 3 over 2, square root of 3 fingers, and then divide by 2. Right, so we have the values. Simple enough, right? And then 1320 divided by 360. So we done the values. Now we just need to determine the quarren. So that is 3.667. 1320 360. Now we only take the decimal part, meaning that we take the decimal part of 667. Where is that? So again, 0.25 revolution, 0.5, 0.75. So 0.67, of course, it is going to be in here, in quadrant 3. So in quadrant 3 is sine positive or negative. So sine is once again y over r. The point here, the y values is negative. R is positive as always. Negative divided by positive is negative. So we have the answer is negative square root of 3 over 3. Square 3 over 2, that's what I mean. Right, so again, try 60, 45, and 30. Of course, try 90 degrees first. If 90 degrees first, we don't do any of this. We will have those examples as well. 3. cotangent of negative 480 degrees no, we're not sure about that. Depends on tangent and cotangent. The reason this one is negative because y values is negative and r is positive. See, if I ask you what is tangent of in the quadrant 3, so for example, if tangent in quadrant 3, tangent is y over x. In quadrant 3, x and y are negative, so negative divided by negative is positive. So for tangent in quadrant 3, it is positive. So we just use the signs for x and y. R is always positive, so we use either x or y, or could be r. Just take two of them, divide, and in this case, it just happen to be negative because negative divided by positive is negative. Yeah. We do a lot of this. Right, negative 480. So first, that doesn't divide by 990 by now because 48 cannot divide by 9. So we know it's not going to be divisible by 90. So 480 divided by 60. So it's 8. So first of all, negative 480 divided by 60 is even. So it's good. That means the reference angle is 60 degrees. I put the check mark there. So it is 60 degrees. Now we do the cotangent of 60 degrees. Right. Now the hand trick actually doesn't work for cotangent. So we have to use a little more than that. Right. Tangent is y over x, cotangent is x over y. So pretty much what we have for cotangent and tangent, they just flip-flop. So what we do is cotangent of 60 degrees is equal to 1 over tangent of 60 degrees. Right, 60 degrees. Tangent is square root of the right fingers 1, 2, 3. So square root of 3. Just use this one. Okay, 60 degrees. Square root of the right fingers 3 over square root of the fingers on the left will be 1. And so we have 3 over 1, we just flipped, and this is 1 over square root of 3. Yeah, we just flip. So we have 3 over 1, and then 1 over square root of 3. So that is the values. Right, now the quadrant. Now the quadrant, negative 480 degrees divided by 360. Negative 480 divided by 360, sorry. This is negative though, don't forget about that. And we'll take the next small part. Now, if we go clockwise, counterclockwise, positive, it will be like this. But if we go clockwise in the negative direction, it will be negative 0.25, negative 0.5, and negative 0.75. So actually on this one, the angle is going to be between the negative 0.25 and negative 0.05. So that in quadrant 3. And finally, cotangent is x over y. In this case, x is negative because that's the point in here, y is negative. So this is positive. So I have positive 1 over square root of 3. So it's going to be positive and 1 over square root of 3. Right, so that is one way to do it. But usually though, when this is the negative angle, remember we can always add 360 to it. So I would just do it like this. So negative 480 degrees, I just add 360 to it. And if it's not enough, add another 360. And then add another 360 to it. We can always do that. So we do for 240 degrees. If we don't want to deal with negative, always add 360 to it to turn into a positive angle. So it's sometimes easier to work with. And so in that case, we can say cotangent of negative 480 degrees will be just cotangent of 240 degrees. And then we do the same thing. Again, of course, 240 is also divisible by 60. Right, there will be more example of this. But let's take 5-minute break. We continue at 2:04. Right. Of course, I'm not continue yet, but just some announcement. So we go a lot slower than the schedule. So later on, if it is keep going at this pace, I might have to post some offline video and ask you to watch later. Because technically we should have 6 hours a week, but we only have 4, so only 2/3 of the time. And at this kind of problem, I do it the regular pace. I don't want to skip any important things, especially at the beginning of this trigonometry stuff. Later on, I still don't want to skip anything, so I may have to do some offline video and then ask you to watch it from another time. But 4 hours a week certainly is not enough. You're talking about, no, this of course is still in section 1.4, so in your homework 1.4 you should see this kind of problem. If you're talking about the homework for the first test, the first test will go over 3 chapters, and we're only on the first chapter here. So my plan is try to go to start at chapter 2 today, and then we have to briefly go to 1.5. So start chapter 2 today, and then on Thursday try to finish that, and chapter 3 by Tuesday. So you should be ready for the first test after next Tuesday. So April 14, after that should be around will be for the first test. Around next Tuesday. Okay, yeah, I just should put on the chat. Yeah, and the test is on my MATLAB. You just go ahead and take it. I think there's the review there also, right? That's the review on my MATLAB already. So the question will be similar to that. But the format of the test is different. They will not give you the feedback on every problem like the homework, and I will have a sample test up this weekend, so to see what the test will look like. There will be time, and there's only one chance for each question. You will see. I post that this weekend, and so get the idea. Right, let's continue. Tangent of 225. Obviously, 225 cannot divide by 90, because if it ends with 5, it cannot be divisible by 90. That's one obvious. Now, here's the trick. Usually, if it ends with 5, try to divide by 45, because if it ends with 5, it cannot be divisible by 30 or 60, right? So it can only work if it ends with 5, try to divide by 45. So 225 divided by 60, that will not work. It's not nice and even, right? 225 divided by 45, right? 5 times. Nice. So 225 divided by 90 doesn't work. 60 doesn't work. 45 is equal 5, which is good. A nice even number. So the reference angle is 45 degrees. Right. Next, tangent of 45 degrees. But let me type this real quick. Now, just tell you. Since the test is at home, it would be unusual if I ask you to, put all your stuff away. So most of the test seen at home, so it goes without saying it's open book and open note. Because it's impossible to ask you not to use anything. But if you have something like this, it will be very quick reference. Right. Tangent 45 degrees. 45 degrees. That the middle fingers. We have 2 on the right, 2 on the left. So square root of the fingers on the right and square root of the number of finger on the left. So that is just 1. Right, that is tangent. Right, so that's good. The value is 1. Now the quarren. 225 divided by 360. .625. So 0, a quarter, a half, and 75 3/4. And 0.625 here is in quadrant 3 because it is between 0.5 and 0.75. So in quadrant 3, x is negative, y is negative, x is negative, y is negative. And we're talking about tangent. Tangent is y over x. So y is negative, x is negative. Negative divided by negative is positive. So we have positive sign and 1. So the answer will be positive 1. Or just 1 pretty much. And of course, in real life, we probably will do a lot quicker than this. But I just want to write all the steps. So this is kind of in the slow motion, if you will. So 2 components, the values and the size. The values use the reference angle. The size use the quarren. Five. Cosecant of negative 30 degrees. Right. Now, this, of course, we could work with the negative angles, but I prefer not to. So the first thing we do is we can always add 360 degree to it. So if you add 360 degree to it, and that will be 330 degree. Yeah, I don't want to work with negative angles, so we just can always do that. Now if 360 is not enough, add another 360 until it is positive. Right, 330 degrees. We work with 330 instead. Right. Now 330. Try 330. Divide by 90. Nope. Is that divided by 60? No. Obviously it's not 45. I'm sorry, I mean 330. 330 divided by 30, right? So we divide by 90, doesn't work. 60 doesn't work. 45 doesn't work. And now 30 is 11, even. So the reference angle is 30. By the way, if it does not divide by 30, just go to the calculator, because there's no thing nice and even after that. Right. Have to try 90 first though. If 90 works, it's going to be different. We don't do any of this. Right. So 30 degrees. Now cosecant. What is cosecant? Cosecant is reciprocal of sine. So whatever we have for sine, we're just going to flip. Right. Sine. I'm sorry, this is bad. Use the reference instead. Cosecant of 30 degrees is 1 over sine of 30 degrees. Right? Sorry. Once we have the reference angle, we use that. Right, 30 degrees here. And sine is going to be the fingers on the right. Square root of that divided by 2. Square root of 1 is 1. So 1 over 1/2. Reciprocal of 1/2 is will be 2 over 1, or just 2. So we found the values 2. Right, now the quadrant. 330 degrees divided by 360. We have 0.916. And if we check the decimal part, which is that, it will be in here, in quadrant 4. Quadrant 4, x is positive and y is negative. And cosecant is r over y. Sorry. R always positive, y is negative. So it is negative. So we have the sine is negative, and the values is 2. So the answer is negative 2. Right, next. Cotangent of 180 degrees. Right. cotangent 180 degrees. So try to divide by 90 degrees first, and it certainly works. 180 divided by 90 degrees. So it certainly works. So if it's the case, don't do any of this. What we do instead, just try to draw it and see where it is. Now, if we have 180 degrees divided by 360, it will be equal to 0.5, right? In terms of revolution, it will be right here. So in that case, we're not going to use this. We're not going to use the hand trick for that. What we do instead, just assign some values. If it is here, just take the point, assign some values. Like for example, I can choose -1 for x and y equal to 0. Because on the x-axis, y must be 0, where x I could choose pretty much anything. So we have x is -1, y is 0, and r, Pythagorean theorem, square root of x squared plus y squared. Sorry. -1 square plus 0 square, so it's 1. And then finally, cotangent. What is cotangent? X over y. X over y. We don't even need r in this case. And divided by 0 is undefined. So whenever divide by 90 degrees, we're not going to use the hand trick. We just choose the point on the x or the y axis, only one of those four, and then choose either x or y to be 0, and then the other one choose 1 or -1. Then we can find the trick values without using any hand trick. 7. Second of 315 degrees. Right, so it's positive, don't have to do anything. By the way, as mentioned before, if it is end with 5, 315 end with 5, more likely it is divided by 45 degrees. Because if it ends with 5, it cannot be divisible by 30, 60, or 90. Only chance for it to work is 45 degrees, and it does. Yes, so it comes out nice and even, so the reference angle is 45 degrees. Right, next, secant of 45 degrees. Secant is 1 over cosine. Yeah, those two are reciprocal of each other. Now we do cosine of 45 degrees. Back to the hand. 45 degrees. Middle finger. 2 fingers on the left, 2 fingers on the right. And the cosine is the number of fingers on the left. Divide by 2. Flip this. We have 2 over square root of 2. So those are the values. That is the values. By the way, if we want to, we can always multiply square root of 2 on the top and square root of 2 at the bottom. So we do that, give us 2 square root of 2 on the top, and the bottom square root of 2 times square root of 2, is 2, where the 2's cancel out. So that's just square root of 2. So the value is square root of 2. Next, the quarren. 315 divided by 360, 0.875. So 0.875 between is more than 75. So it will be in here. Quadrant 4. And in quadrant 4, x is positive, y is negative, and r is always positive. And we want secant. Secant is over x. R is positive, x positive, so it is positive. So that gives us positive, and the value is square root of 2. So secant is square root of 2. Right. I apologize if you took trigonometry before in high school or somewhere else. Obviously, you will not go over that this slow, so you might already know all of this. But I just want to do extremely slow, go over every possible details about the problem. So again, when we have an angle, trying to find a reference angle, and usually, unless it's divided by 90, we use x, y, and r. If it's not divided by 90, try 60. If 60 doesn't work, go to 45. If 45 doesn't work, go to 30. If it is divisible by that number, that will be the reference angle. And we find the trig values for that reference angle. And then we use the quarren to determine the size. Right. With that, we go to the next section. Right. We will skip a few things in this section because later on when we go to chapter 5, we'll go back to this. So for now, I'm just go over the identities, a few examples, and move on. Right. 1. Fundamental. One reciprocal. It's the quick reference card. as you see, sine and cosecant, what we do, we just flip-flop the ratio so they are reciprocal of each other. So I would say cosecant is reciprocal of sine, secant is reciprocal of cosine, and tangent, cotangent, reciprocal of tangent. Right. Next, quotient identities. I will write the identities first. Tangent equals sine over cosine, and cotangent is reciprocal of that, right? Cotangent and tangent just flip-flop. Right. So why is that though? Let's see. Sine over cosine, right? Sine over cosine. This is the proof. Sine over cosine. Sine is y over r, and cosine is x over r. Divide fraction is multiplied reciprocal, so we're going to multiply by r over x. Y over r divided by x over r flipped, r and r cancel out. We have y over x, which is tangent. Right. Next, Pythagorean theorem. Pythagorean identities. When we say sine square, what we really mean is sine of x square. So the square, actually, we take the trig function first and then we square it. And not this. This will mean we square the x and then we take the trig function. So that is the only thing we can think of. Right. Sine square. Let's go sine square. Sine is y over r, and cosine, right? Cosine is x over r. When we square, square the top, square the bottom, square the top, square the bottom. Common denominator is r squared, x squared plus y squared. Pythagorean theorem, x squared plus y squared is r squared. So it is equal to 1. Right. So next we go to the hexagon trick. By the way, when we have this, we don't need to memorize any of the formulas above. So it's 9 mnemonic. So the hexagon trick, of course, we draw the hexagon like that. And so I recommend that you put that in the 3x5 like I do here. So I have one definition, one with the hand trick, and the next one is the hexagon. So the hexagon will be put tangent on the top. Just I've used with the pencil. Where's the pencil? and then cut that line in half, and then kind of do just draw one big asterisk. Tangent on top. Opposite to that is cotangent, and then sine and cosine. Opposite of sine is cosecant. That is reciprocal. Reciprocal of cosine is sine. So we've kind of formed like the hexagon. In the middle, put 1. And after that, draw this pattern. Go up and down to the left. Up, down to the, at right. This should be secant. Sorry. Yeah. And go up and down to the left. So this is the hexagon trick. You can search that online. I found this online. I didn't know this when I took trigonometry. That is the beginning of the internet age. Like 20 years ago. Anyway, so how does that work? Right. First of all, the reciprocal. Whatever opposite to a trick is reciprocal of each other. Tangent and cotangent reciprocal of each other. Sine and cosecant, cosine and secant. Right? Now how does that work? For example, I can say, let's pick anything. A tangent on the top. I'll go with tangent. So when we have tangent, I should have a toothpick on. Anyway, if we have tangent on the top, there will be 3 ratio, right? Tangent on the top here. We have sine above cosine, so that will be a ratio. Also, there's 1 above cotangent. And then 1, and then also secant above cosecant. All of those ratio works. So that's the nice thing about the hexagon trick. I try something else. How about we go with, put cosine on the top. Never mind, I should put this in the 3x5 first, and then we rotate. Right. I need the 3x5. Right. So I draw one big asterisk. A big asterisk, tangent on the top, cotangent at the bottom, and then sine, cosine, opposite will be secant, and cosecant. Right, and then we can connect it to have a hexagon. It's much better on the note on that side. And then we have one in the middle. This is called the Hexagon Trick. You can search it online. However, they don't put it as nicely as, they don't draw the nice picture as I have here on the note, that is. And then the parent, up to the left, up to the left, and up to the left. So this is called the Hexagon Trick. Right, now we did for tangent, right? Now let's rotate and put cosine on the top. Cosine now is on the top. If cosine on the top, what we see is cotangent over cosecant. One over secant. And then sine over tangent. Yeah. So whenever we put one trig function on the top, there will be 3 ratio. Cotangent over cosecant, 1 over secant, and sine over tangent. Right. So the hexagon trick will take care of all the ratio and quotient identities. Now the Pythagorean identities. We have this parent. So we have cosine square plus sine square is 1. One plus tangent square. 1 square plus tangent square is secant square. And cotangent square plus cotangent square plus 1 square is cosecant square. Right. So that's what hexagon trick we do. Help us to memorize all of this. And I recommend you to have one quick reference like we have with the hand trick for the special values or the definition, and then one for the hexagon trick. Right. 2 examples. First, if sine theta is equal to 3/4 phi cosecant, sorry. Right. The hexagon trick, we asked to find cosecant, so rotate that so the cosecant on the top. Cosecant is secant over tangent. We do not know anything about that. It's 1 over sine. We do know sine, so we're going to use that. Cosecant is 1 over sine. Because cosecant is opposite from the hexagon of sine, so they'll be reciprocal of each other. 1 over 3/4 multiply reciprocal, so we just flipped, and that's it. B. We know sine is 3/5. Cosine is negative 4/5. Phi tangent and cotangent. Right, so we need tangent, which is good. So put tangent on the top, upright. And for tangent, we have 1 over cotangent, sine over cosine, secant over cosecant. We're going to use sine and cosine because those are given. Sine is 3/5. Cosine is negative 4/5. Right. Divide fraction is multiplied reciprocal. So 3/5 multiply. We're going to flip this. Five and 5 cancel out. We have negative 3/4. Right, simple enough, right? How about cotangent? Right, cotangent, put that on the top. Cotangent is equal to cosine over sine, so we can divide them, or 1 over tangent, or cosecant over secant, which we don't have cosecant over secant, so we're not using that. So either we use 1 over tangent, or cosine over sine. I use that. And all I do is just flip. So simple enough, right? So whatever the question gives us, we can use the trig identity to find it. There's obviously a typo here. C. If tangent is 4, oh, never mind, that's correct. Secant is negative 5 secant and sine. How do we do this? Right. We don't know anything about secant. We only know one value. So there are two ways to do it. First, I use tangent and secant. The only relation of tangent and secant is this. So we have 1 square plus tangent square, secant square, the Pythagorean identity. Right? Yeah. Pythagorean identities, there are 3 of them. 1, 2, and 3. Right. 1, tangent square, 4 square, secant square, don't know. So 1 square is 20, 1 square is 1, 4 square is 16. So this is 17. By the way, if you didn't write that out earlier, it is very important. When we write secant square, we really mean is the secant first and then we square. So we have secant square equal to 17, taking square root on both sides. Square root on both sides. Whenever we do that, we have to put plus or minus on one side. So we have secant square cancel square root plus or minus square root of 17. And then on this problem, this particular problem, secant is negative. So we will choose the negative sign. So secant is negative square root of 17. Right? Now we have secant, and how do we go to sine? Right. Let's see. Back to the hexagon. We have tangent, which is good, and we have secant. That's all we have. How do we go to sine? Right. There's a lot of way to do that. By the way, if sine secant is equal to that, how do we go to sine though? Let's put sine on the top. Sine on the top, tangent over secant. Once again, if we want sine, it will be tangent over secant. Right? Tangent for secant, negative square root of 17. So we just say negative 4 over square root of 17. Right? So the hexagon certainly works. Put sine on the top, and then we have tangent over secant, 1 over cosecant or cosine over cotangent. And that's what we have here. Alright, that's one way to do it. Another way to do it is let's go back. What we have is tangent is 4, secant is negative. If all fails, what always works is definition, x, y, and r. So we start with the definition. We say tangent is y over x, which is 4, or we can say 4 over 1. Right. So it's very tempting to say, why do we let y go to 4 and x equal to 1? We could not do that. We know that what we know for sure for now. Next, secant is negative. Secant, what is secant? Secant is r over x. Remember, r always negative, r always positive, right? And when we divide them, it ends up being negative. So from here, what do you see what do you think x has to be? Right? It's always positive. X could be positive, could be negative, but the ratio is negative, so x has to be negative. If x is negative, we're going to put negative there, and when we divide them, it has to be 4, so y has to be negative as well, because negative divided by negative will be positive. So with that, we say x is negative 1, y is negative 4, and r square root of x squared plus y squared. Negative 1 square plus negative 4 square, that's 17, so square root of 17. And finally, we want secant and sine. Secant is r over x, r is square root of 17, x is negative 1, so this is negative square root of 17. And then sine is y over r, y negative 4, r square root of 17. So like I said, when all fails, go back to the definition. Definition using x, y, and r always work. We don't need to use all the trig identities like we did here. Right. So what I actually want to go is, like I said, the section 1.5 here, we will go back to it when we go to section 5.1. So we have to skip the rest for now. We will not do any identities for the next one. So what I want to do is go to the next section, 2.1. We'll get back to the identities when we go to chapter 5. But for now, just want to start section 2.1. Trigonometric. Of an acute angle. One. Right triangle. Trigonometry. Actually, I think if it is back when I was in high school, this is the first trigonometry that I have based on the right triangle. Trigonometry. There are 3 ways to define a trigonometric function. The first one using x, y, and r. Now this is the second way. Only works for an acute angle. So we focus on acute angle in a right triangle. A. Definition. So let's draw a triangle here. We have an angle theta. opposite to the angle theta, what we call is the opposite. The hypotenuse is the longest sine. And then the adjacent. It's adjacent to the angle. Right. With that, we define sine is opposite over hypotenuse. Cosine adjacent. Again, this is the way we define it. Hypotenuse. Tangent. Opposite over adjacent. Right. Once we have those three, we're just going to flip them. Have the reciprocal function. Cosecant. Hypotenuse over opposite. Secant. Hypotenuse over adjacent. And cotangent. Adjacent over opposite. Right. Oh, actually there's nothing new here. If we're trying to draw this into the coordinate system, we don't add that. This is the y-axis. The x-axis here. So actually what we have is, this is the x values for that point, for x and y. This is the y, and this is the x values on the x-axis, y values on y-axis, and the hypotenuse is r. And then that will be consistent to the definition we have earlier. Sine is y over r, right? Sine is y over r. Opposite, hypotenuse. Cosine, x over r, adjacent over hypotenuse. So there's nothing new. We just define that for a triangle. That's all. And tangent, y over x. And because the other one we can flip. Right. So actually, like I said, the first thing in trigonometry, that's what will probably what you have. Right. Before we go though, I just want to write the mnemonic that will help me to memorize all of this. So the way I memorize this is, right, sum on hippie cut another hippie creeping on. Yeah, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent opposite over adjacent. Right, that's one of them. Of course, you find online there's a bunch of similar thing, or I could say the old angel sitting on heaven carries a heart. Right. So tangent is opposite over adjacent. sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Right, because there are a lot more. If you can search online, that's very easy to find. Right, so again, that definition is consistent with what we have using x, y, and r. The difference here is this one only for an acute angle. By acute, we mean from 0 to 90 degrees. Actually, it's less than 90 degrees. Or bigger than 0, so a positive. So anything between 0 and 90 degrees, not equal to. Right, we run out of time, so I have to stop here. Like I said, if we run out of time, if we don't have enough time to go over all the material, I might have to record some videos and ask you to watch it at your own time, because 4 hours a week is not enough. Anyway, I'm going to stop the stream here unless you have any question. Otherwise, have a nice day. Thank you for being here. Yes, right now I only post the homework for the first 3 chapters because that's for the first test. After we take the first test, then I post more. But for now, the first 3 chapters for the first test. And the test should be sometime next week. Should be after next Tuesday. Alright, I'm going to end the stream now. Yes, the whole homework and the whole reviews, yes, there are no due date. Everything is due at the end of the semester. Yeah, so that including homework, test, review, everything except for one, which I'll talk about that. That is the core artifact. If you read the syllabus, it's already mentioned. But in terms of homework, test review, and test, there's no deadline for it. There's no deadline for them. Just turn in at the end of the semester. Right, I'm going to end the stream now.